Okay. Yeah, the recording missed all the important
Oh,
talk about the
so
SIMP pin 46 being an open or a cold solder joint, I guess.
You should have run with that. That would be no record. You missed a solder joint.
I guess the other side we I got Paul's stuff off to him uh Friday, so he's getting what we decided to do there is I'm sending him a different 8080 board, and I'm keeping his SBC 100 for now. And then he's getting he got an FTC Plus, a 2SIO, so he's got
Cool. He's got the setup.
32. So
So
just kind
yeah,
of
he's
the
getting
basic
a
Altair.
basic setup.
Yeah,
That's great. That'll get him going.
yeah, it all ran within my back plane without a front panel. So because he doesn't have a front panel, so all the jump on start stuff works.
Oh yeah, yeah.
That's great. He'll be excited.
Yeah, the only thing I have a reset button, which I use a lot, but I don't know if he has a reset button wired in. But he can do that on his motherboard.
That's easy enough. Yeah.
Yeah.
Yeah, it's just a few things there. I think actually I swapped out the resistor on that reset button on the
Yeah.
9, and it worked perfect. Thanks, Tim. I appreciate it. The 10K, I think it was you
It's 10
suggested.
ohm. 10 ohm.
Yeah.
It's
Yeah.
just a
Not
little
10K, 10 ohm. Yeah, that's what it
right.
was.
So it's a little better than shorting between 5 volts and ground.
I didn't want to do the short. Yeah, that's why
Yeah.
so.
And that 10 ohm came off John's extender card.
Yeah. Actually, it was I built an extender card and I looked at the schematic and I looked at, wait, I did use 10 ohm there, so it's like, okay, that makes sense. Good catch. So
when I built it according to the drawing, it just wasn't resetting cleanly.
yeah,
And I looked at that one because I'd used the reset on that and it was perfect. And so I said, oh, so yeah, 10 ohm, boom, done.
yeah.
Yeah, I've been making slow progress on my punch tape reader.
Oh, cool.
Oh, nice.
The card is built apart from a jumper. Those
Yeah.
3 little pads there, that's for a ACK or NAC basically for a jumper, and the common is at the top rather than in the middle, and it's not spaced for a.
Yeah.
So I did that, and then I 3D printed a couple of these.
Oh my
Oh,
God.
nice. It's a Ferris wheel. No, I'm kidding.
So I can crank, right? I can crank the tape. So I'm working on that.
That is so cool.
And then
That
I bought a side quest, which is a 2SIO, to build because I was going to modify my SSM IO4, and sorry, that's an IO2. So I found somebody that sells IO2 replica cards,
Yeah.
which is a much more kind of generic. So I thought, well, I'll use one of those and just build a custom IO card for the reader that uses 2 input ports only.
That's the SSM IO2, right?
IO2, yeah. I found somebody on like eBay or whatever that sells it, and even sells a little part kit of the basic parts.
Oh, that's nice.
Yeah, I actually saw that. I saw that listing.
Yeah, so I'm going to be putting that together over the next couple of weeks and seeing if I can make that work and match the 16-pin connector on the punch board. So maybe in a few weeks I'll be to actually try booting 50-year-old Microsoft Basic.
Why don't you do a share computer on the screen and walk through the simulator? It's not just for us, it's for other people that look at the YouTube videos too.
Yeah. But by the way, Patrick, you were right by just taking that by loading the CPM3 file that I already had that I knew worked and taking what John's file and just putting it as another drive, I was able to access the stuff on it. For some reason, that little, I called it a versioning error, but it really wasn't, I guess.
It is. Like I said, we were talking earlier about some things that I don't really dig about Altair Z80 simulator.
Yeah.
That's one of them.
It seemed like a lot of people didn't. Well, honestly, I wasn't sure if that was just at Altair, because I think you mentioned that it was something introduced for the PDP, wasn't it? Or the people, we're talking PDP 8 or PDP 11?
No, it's just Altair.
Is it just Altair? Okay.
I mean, the PDP might have its own issues. I've never run with it. Hang on, I'm trying to figure out. Oh, there we go. I don't know if
There, area starting to see something.
Like, is this big enough? Can you guys see it?
Oh yeah.
Yeah.
Okay, good. So I mean, I'm not 100% sure what all. I was just going to kind of give a little bit of overview about what it is. Um, so Altair Z80 simulator, it's designed to run Altair software. It has built in when you run it just from if you run it, I should just run it. If you just run it by itself, you get a little command prompt. It's done. It's kind of like having a command line interface. You
Yeah.
can type help. These are all the commands it does.
Yeah, Control E to get if you're running Altair software, you click
Yeah, if you're
Control E
running.
to break out of it and reset if you have to.
Yeah, so it has the idea of devices, and these are all the devices that are built into the
Oh, wow.
simulator right now. Disk is the Altair 88 disk controller. You got a disk 1A, disk 2, disk 3s. The SS1 it has a clock calendar in it. There's your Crememco FDC. You got TUART SIO ports. I'm not sure anyone know what the IBCs are. I don't know what the IBCs are.
No.
You got a JDD, a Tarbell, the ICOM disk controller, the Disk Jockey 2D.
I had one of those.
Anyway, so it has all these devices in here. By default, it just comes up with the Altair disk controller. Well, I should start at the top. It comes up with the CPU active in 8080 mode, I believe. Their version of the 2SIO port. There's a thing called a SimH pseudo device that I'll talk about. A printer device, a punch tape device. And I think those are the only things that's enabled by default. So if you wanted to, so the way this works, let's say you were working with, you wanted to work with the Tarbell for some reason. So set Tarbell enable that. So now that enables that device. We've essentially now plugged the Tarbell controller into the S100 bus. So now if we do a show dev, when we get to Tarbell, instead of saying disabled, it'll let you know it's on IO addresses F8 through FC, the DMA is not enabled, the PROM's enabled, and it's in single density mode, and it'll support 4 drives.
Will it say anything if there's already a device using that same IO port or not? Or that's pretty
No,
much up to you. Okay.
I don't believe so. I think the one you did last will take over the previous one.
Okay.
Gotcha. Okay.
Like for example, I'll disable it. There's some things that the SIO, the built-in 2SIO driver or device does that makes it not work with a whole bunch of stuff. Especially if you want to connect like an actual RS-232 port to this and do your IO through a serial cable, an actual serial cable. So I wrote these wherever they went, these M2SIO1 and M2SIO2. So that's your port 10 and your 10 hex and 12 hex.
Yep.
So those are on the same port addresses as the SIO ports. But if I enable them, now it just says this is on ports 10 and 11. And so 10 and 11 will now go here. It won't go to the SIO one here.
Yeah. So SIO one's still active, but not.
Oh, and it moved. It moved. Did you? Yes. So there's the 12 and 11 are 12 and 13 are still there.
Yeah. So 12 and 13 would still go to the SIO one, and 10 and 11 will go here. I could enable M2SIO1 also, and that'll be 12 and 13.
Right.
And what it does inside the simulator, there's just a table of 256 entries.
That makes sense.
Yeah.
And you just sell it if you get an input output request on this port number, send it to this function. And if you undo it, it has some defaults and it puts it all back to the default stuff.
That's a huge improvement over real hardware where they fight over the other port.
Yeah. Yeah, so basically the last one you did seems to win.
Okay, thank you.
So that's kind of how you can configure it any way you want, and if you want to have SBC 200 enable. So now I have now I've essentially plugged in the SBC 200 card, and it's using IO ports 7A through 7F.
Yeah, I remember those.
And you can type show in the device name. It lets me know I don't have anything attached to it. It's currently acting as the console port. The monitor is enabled and the DVD BIOS is enabled. The memory dump command, I think this is at a D00. Maybe it's a C00. I can't remember what's that. F00.
E00. You're talking about the S200?
Yeah, is it E00?
I think it's E00, isn't it?
Yeah. So in the simulator, you can dump memory.
Okay.
So now I'm dumping the monitor. That's basically the monitor ROM is loaded from the SBC 200, and I think F00 is DD BIOS. So that's
yeah.
that's the BIOS. You can so right now, if you do show CPU, we have 64K of RAM. We're in 8080 mode. It's using the Altair just RAM. The Altair ROM's enabled, which is broken, by the way, which is another thing I'm changed.
So you can't just load your own random ROMs yet, right?
You can. In fact, that's what I was going to kind of show one of the examples when we get down there.
Great. Yeah.
So you can do set CPU. Well, actually, I should do this. So this is kind of a broken disk bootloader. For some reason, they decided to start reading sectors from sector 6 or 8 instead of 0. So it doesn't work with any of the standard Altair disks. Just kind of weird. But now if you do set CPU no Altair ROM. I think it doesn't clear it out. But now this is just RAM. We can write to it. In fact, you can do deposit FF0000. And now we have a 00 there.
Yeah.
Okay.
So you can disable that ROM and load your own in, which is what I do all the time. I can never figure out why. How come then you download all these disk images from DRAM? It's like none of them will boot. What is going on here? So I ended up just loading the disk bootload off the Altair, the MITS one. Every time I want to do that stuff. But their CPM stuff runs because their bootloaders all are designed to load from sector 6 or 8 or something. I'm kind of. So, I mean, does anyone have any questions so far about?
Well, how do you set it up so it's only going to use 8080 code?
It is right now. If I do show CPU, it says it's currently in 8080 mode.
Okay, what's that AZ80 after that?
That has to do with this will support different memory cards with banked memory. Like I just added the Expando RAM. So that just says it's in basically the Altair Z80 basic. There's 64K of RAM.
Okay.
And it's not banked, it's not anything. There's just RAM there. You can change it, like if you hit a halt instruction, do you want to stop and exit the simulation, or do you want to just keep spinning somewhere? Now it says no Altair ROM instead of Altair ROM because we disabled it. I'm not sure what the switcher is. This is kind of cool. I added this PO. That's programmed output. If you
that's the output byte.
Yeah, because they never had. If you wrote to FF, it just would never do anything.
Right.
And now, if you output to FF, it'll just print on your screen, PO colon and the value you got.
Oh, awesome.
Because I was like, that would help with debugging a bunch of this stuff. I wish the Altair had programmed output. Right. So you can enable the programmed output. So if the program you're running does support it, you'll start getting output on your screen on what the programmed output is, what's being put out to FF. Let's see. Help CPU. So.
Oh, wow.
These are, so you can examine, these are registers, what they call registers. So
Mm-hmm.
there's your AF register, your BC, all these registers, but there's some special ones. I think it's SR. Yeah, SR.
Oh,
The
front panel
front
switch.
panel switches.
Wow.
If you need your front panel switches to return a certain value, you can
Mm-hmm.
deposit that value into the SR register, and then if you do an input on FF, you'll get that value. So like if you have, I know like some of the older bootloaders, you have to like set switches to load it from the console, but then you want this to load it from, there. So you can do like deposit SR, you needed 80 or something.
CPU switchers. Mhm.
Yeah, so now if you do an input on FF, FF's going to return an 80.
Is the switcher port so that you can have multiple CPUs and flip between them?
That's what it looks like.
Okay, because it's like I've got one of those CompuPro 8088, 8085 cards, and it has a port for switching between the two processors
That
on the top.
must be it. Um, Yeah, and that's what, so kind of what it just kind of on the track of that. See,
Hmm.
all this stuff is built into the CPU device. Your switcher, your
Right.
RAM, your banking. I mean, all this stuff is built into the CPU device.
Hmm.
The simulator I'm doing, it's the CPU device is going to be the CPU, and it's going to care less about anything else. And I made like a bus device, which is going to
Right.
mitigate between all this stuff. So I'm hoping if you wanted to be able to like switch between like two CPUs on the same card,
Hmm.
you would create a device for that card, and it would have the output ports and all that
Right.
stuff, and it would do everything for you. The rest of the simulator can care less.
Right.
Because when you start getting into certain things, they've kind of put so much stuff into one place. If you want to deviate from that, it gets to be really hard.
You know what we really need is an external board with an S100 card edge connector on, so you can connect the physical card to the simulator. Because
Yeah,
if
Like
you've
that.
if
that,
you've
that
already
that's that's kind of in line with what I was thinking. Is it would be nice if you could run it over to a backplane and do stuff.
just having a single card slot would be enough to make testing super simple.
Yeah, I mean you can't get into the CPU from the
Right.
simulator, so you couldn't. I don't know that you could look at
Yeah.
registers.
Right. But if you're building, cards of your own to test,
Oh yeah.
that would
No,
be
no,
so much.
absolutely. I
And
think that
it doesn't feel like it would be horribly hard, he
no.
said. He said not knowing it, having a clue how to do it.
Yeah, well, one of the things I've been on my list to do is I really want to get like I know John Monahan I think has a Raspberry Pi board and
Hmm.
there's the Chameleon board or something. But yeah, get something on there that it can at least monitor the bus, start the CPU, stop the CPU, do all this stuff. And then where you can just generate signals when you're testing a board.
Hmm.
Yeah. Yeah, that'd be awesome. Have it be actually, yeah, nah, yeah, have it be the CPU. Have Altair
Right.
Z80 like, man, that'd be fun.
Yeah.
Uh, so this is a lot of stuff here. This is you can examine all these registers. It has a bunch of settings. Set CPU
Mhm.
20 KB. Now you have 20K RAM. This is where you say whether you have a expando RAM or whether you have
Right.
this, what kind of banking
Hmm.
system you have. There's just a lot of stuff.
Oh
Gives you a
yeah.
lot of flexibility. And if you just type like
Hmm.
help anything, help CPU will show you that. Help M2 SIO
Oh, awesome. So the
0.
built-in help, it looks like it's really well thought out.
Yeah, it'll show you like all the
Oh,
internal
awesome.
registers you can look at on the SIO port. It gives you like instructions on if you want to connect,
Mm.
COM3 to, COM3 on your host to the SIO port.
Right.
It kind of tells you how to do that. Um,
I like that idea. I haven't played around with that, so
We put that in. I really wanted to start. I wanted to test PC to flop, flop to PC get do X modem and
Mhm.
stuff. And
yeah.
I just couldn't. There's no way to do it.
Right, right,
Once you
right.
got a real serial port on it, yeah, then I could just talk to TerraTerm or whatever
Mhm.
and actually
Yeah.
do X modem over it and get it working here before you try it. Because I think I had to do PC get and stuff. I've done it for different serial boards that I don't even have the boards.
Mhm.
So I just wrote simulator for it and then sent it to the people that had the boards, and they're like, "Yep, it works." So, it's really flexible. Again, the memory dump is nice. You can. I think this works. You can examine any of these registers,
Mhm.
see what's going on. I will. Anyways, if you just run Altair Z80 all by itself, it loads up in its default configuration with just those devices, not doing anything
Right,
else. It supports like any files. Oops,
right.
I can type.
Mhm.
So now if I do, so this is one I was just gonna show how to boost CPM and do some cool stuff. So if you do altmon or Altair ZD and like altmon.ini, now when it loads, it's going to run this ini file, which is going to set the CPU to a Z80. It's going to get rid of the Altair ROM. It's going to turn off their sleeping to make everything else break. I made like a DDT type display. And that's what set on and error on. Basically, it set on turns on the on feature, and then on and error run the register commands to display the registers. I'm going to attach one of Mike's 8 megabyte disk images. I'm going to load the disk bootloader into FF00, and then I'm going to go to FF00 and execute the disk bootloader. So if all well works, now I got CPM.
Yeah.
So what I was going to kind of show you is, so when your simulator's running, Control E, I think it's the same on all operating systems, I think. So if you press Control E, it's going to stop the simulator. And this is what I was talking about, where it shows you all the registers.
Oh, beautiful.
That's a register output that I made.
Yeah.
Because before you have to you have to like examine AF or examine this or examine that. And when you're single stepping, it's like, oh my gosh. So now that we're out, I'll show single step because the S command, we can now just single step through CPM. And now you can see, and this is awesome for just learning how programs work, learning assembly even, because you can even see, and I'm going to do something else because I'm not as fluent in Z80. Yeah, so now as you're single stepping, you have all your flags. You can see back at C79, there was a return 0. You can look over here. Yep, 0 flag was set. So it returned. We went back to C807. We had a jump 0. It's like, yep, 0 was set. Then we got a call. So you can see we went from C809 to C77. We did an in on port 10. So now our A register has what we received from the 2SIO.
The status.
Because we're in the loop looking for keyboard input.
Mm-hmm.
Yeah.
And then we're going to test the 1 bit, which is not set because we don't have any keyboard input, and then we return. So I mean, this is just I just find this amazing.
Oh yeah.
When you're learning to write software or debug software or something, just it's amazing. I'll show another good one. Set CPU history 128. Oops. Equals 128. Now I'm going to just tell it the single step 200 instructions. when you have something like weird happening and we don't know how it got there, now you can do show CPU history,
Oh, wow.
and it
Oh,
has
that's nice.
it has the last whatever you set history to. It has the last 128 things it did, plus all the registers, all the flags. So
God,
sometimes that helps.
who needs a debugger when you got this?
Yeah. Let's say you got something going on here at C80C. You can do break C80C.
Mhm.
Show break. So now we have a breakpoint set. I don't know why it has C809. Oh, that's why I was single stepping. So now we got a breakpoint at C80C. If I just do C to continue, every time we hit C80C, it's just going to stop. And it still has the C801 from single step. I think that's a bug.
Right.
Set no break. Huh. I don't know what that is. I think it's a bug. The breakpoints, the E, at the M, you can set a breakpoint on just if a certain memory location is accessed. I think you can set a breakpoint if a certain instruction is run, and E, you can set a breakpoint if it executes if the program counter hits that location. So if you have like, how is that byte getting changed? It's not supposed to change. You can set a breakpoint on the memory location, run your program, and it'll stop when that memory location gets read or written to, which is also amazing. Yeah, so I just have Altmon on here. I made a submit file to assemble it. So yeah, I should show you. I think we talked about this last time. This arg.com and w.com.
Yeah.
Yeah.
But those are programs that read and write files between CPM and your host system. So on my altmon.sub, it reads altmon.asm from my computer, it assembles it, and then it writes a hex file and the print file back.
I used that extensively when I was writing my monitor for John's Z80 card.
Absolutely. So
Yeah.
now these are my hosts. I can use VI or whatever. I can edit it. But we also made this hex file. Oops. Altair Z80. The load command lets you load files into RAM. If you just do load, it's going to load a binary file. So you can do like the DBL loader, dbl.bin, I think. Load it into, I'll just load it into F1000.
Right.
So now it says 256 bytes loaded at F00. If I F00, there it is. You can also set, if you do -H, it'll load a hex file.
Cool.
So I can load altmon.hex that we just assembled, and it'll say it loaded 1,013 bytes into F800.
Yeah.
And then we got, if I do go F800, boop.
Yeah. That's great. That's how I was playing around with Altmon on it. That's cool.
Yeah,
looking at the display when you do the memory dump, when you're doing a dump on like a ROM or another program, it would be neat if further to the right it listed program code in assembly language.
that's hard. You can do that. Hang on, I'm glad you brought that up because I could show you that. Let me do. I showed you the EX. So the EX, like I can examine just a byte of memory or examine 001. I think it's a dash. If you do EX-M for not opcode. What's the other word?
Not mnemonic.
Yeah, mnemonic, I guess. And then if I do 000 through 000F, now you can see what's there.
Oh, okay.
It doesn't do it on the memory dump.
No. Well,
Because
it's
that's a whole
hard.
lot of code. But you can but you can't. Well, yeah, because all.
You wouldn't know where the starting point was of your code. If you start in the middle of a multi-byte instruction,
Yeah.
you're going to get weird results.
So like FF00 through FFFF. So now this is the this is the bootloader.
Yeah.
It'd be really cool to be able to load in like a symbol table, and have symbol references. But this is pretty good.
Yeah.
So then the next question is, if you can view it, can you type it in like that?
You mean do inline assembly on the fly?
Yeah.
That's an interesting thought.
Set a memory address and then the mnemonic and the
And then
operator, whatever you call it.
I've never tried that. Deposit 00.
It's interesting. I know there's a book or something about assembly interpreter type thing. It was a book. Somebody wrote a book and gave examples. I thought it was kind of interesting. I didn't buy it, but I've seen it
Yeah, well,
put out there.
wow.
I just put a 10H there. I mean, an N10H, and it took it.
Right. Looks like it does. Wow.
Yeah, I've never done that, but
That's
I don't know
cool.
if you can have it just like prompt for the next memory address and prompt for the next memory address.
Yeah.
That's something I would have to add.
Yeah, that would be handy again too for learning assembly language, is typing it in a little bit of a program and then run it and test it and
Right.
Yeah. Now, my preferred method would be to make a small program, assemble it, make the hex file, and load the hex file. 'Cause
Likewise.
that's a lot less labor intensive, but
And it's a good flow for when the programs get bigger.
yeah.
Yeah,
well,
and
yeah,
this
but when you're learning, you're not using big programs. You're just trying to type little sets of programs.
Right.
Yeah, but
Yeah.
you'd probably type it into you probably have a text editor and be copying and pasting.
Hell yeah.
Yeah,
Notepad or whatever you like, Notepad or was it
Yeah.
Sublime or
I mean,
Vi?
that's what I use. I use Sublime. If you're working in Z80, Sublime even has a plugin that recognizes, doesn't have an 8080, but it has a Z80 plugin. So it recognizes and, highlights and colors all your code, which is kind of nice.
Yeah, so we just made a real small program.
Yeah, but doing it with the read and write and putting in a submit file, it's so fast.
It is.
Yeah.
It's amazing.
So
And again, it's a good habit to get into when you're going to be going to hopefully bigger programs. You might as well just start doing that flow.
yeah. I'm still learning basic.
That's
Now,
right.
I'm glad I kind of did this too. CPM does not like Unix formatted text files.
Files.
Oh.
Yes.
Yeah.
Old DOS to Unix, Unix to DOS.
Yeah.
Oh,
Yeah, I've been living with that one for a number of years.
yeah.
So there we just made a real small program. And yeah, it's just gonna just do the same thing over and over again. There's I just, if you guys want to look into this, I do want to show you this. Does you guys want to see anything else like from where we were?
Sure.
I mean, do you have any questions like of like how to do something or what?
No, You're good. I think if you have something you want to move on to that I think I'm good where we
Well,
are. So if you go ahead.
I do want to show you this. What's a good one? It has its own like scripting language. So
Mm.
there's a lot more you can do with this. I think you can even have it like assemble, breakout, go back to the simulator, run simulator commands, execute your thing again, your simulator, tell it to break out again. I mean, you can have it do so. These are a bunch of test programs they wrote, and
Oh God.
you can kind of see what it does. So there has these expect things. So when you
Oh, send expect. Oh my
yeah,
God.
so if
Oh,
when the A prompt shows
yeah.
up, send a carriage return and then go to the floppy SSD thing. If you just get that, go to fail, reset the darn. I mean, there is so much stuff you can do with the simulator
Wow.
that
They
I'm
included expect. That's great.
yeah, but I'm just trying to. I don't know if I can make this
My
run.
God.
So this is like the SDS SDOS test that I
Yeah.
started working on. And yeah, so I basically told it to it loaded the disks. Once it got the A prompt, it said format. It sent all the parameters of format to format drive B. Um, then it transferred all the files from A to B, and it's checking, for the results. Then it did a directory on B. It made sure there was 62 entries, the disk space is right. Did a stat, this. Yeah, that's just amazing what you can do with that. And they've written these tests for all these different systems. There's another on, I think it's on Peter Shorn's GitHub, and we're trying to add more stuff. He has a repository called packages, and here you can get like tarbell disks and any files. The SDS CPM2s and 3 SDOS, MS-DOS, different versions of CPM. And in his repository, you should have like an any file, disk images that should just run that particular operating system.
Mm.
We'll see.
I know on his website that he has a whole bunch of OSs listed because I've downloaded
Right.
CPM 2.2 and
Yeah.
CPM 3
Is
and
there a link to
e
that website?
What's that?
Can you put the link to that website in the chat?
Let me see if let me find it. It's get get I don't have him in here. I just have my repository cloned. Oh. Yeah, I don't know why I don't have his in here. Yeah, I don't know where it is off the top of my head, but I'll find it. Oh, I can find it.
So that would be a good thing to have in the chat to go with this video.
Well, yeah, he has the Git repository, but he also has just a web page that I think I just grabbed it from his web page. I think I just searched Altair Z80 and it
Yeah, and
pops up in the web. Go
he
ahead.
has like different operating systems and programming languages, and
Yeah, yeah, and the different versions of the of
let's do
his
that.
Altair Z80.
Yeah, put the link in the chat.
Yeah, we're trying to find it.
He's trying to find he has to get to it. I think I just looked for Altair Z80 and he came up pretty quick.
Okay.
There you are. Yeah, right up top.
Oh, I've seen. Yes, I've pulled stuff from that site before.
Yeah, that's kind of where I start if I'm doing something.
Now, the interesting thing is a lot of the disk images and stuff will not work on an actual hardware. Like it won't work with the
Right.
Yeah.
with the ESP32. It won't. It's like simulator centric.
Mm-hmm.
Okay, that's good to know. I don't know if I've ever tried to run it anywhere else. I mean, I've usually brought it down for the simulator itself. So, okay, that's good to know.
Here's my- How do I chat? That's what I
By the way, is that the view out your back window?
want. No, that's downtown.
Okay, that's cool. That's a great picture, man.
Yeah, yeah, my son took that picture.
Oh, that's cool. That looks like professional. I mean, honestly, that
Yeah,
looks great.
the scenic city.
Yeah.
Um, so yeah, I think that's pretty much all I wanted to. I was going to show. Oh, I can show. I did want to do one more thing. There is some. There are some graphics modes, like this is a Sol 20 that you can do. Who I meant to do something first. It had like end files, Trek 80. I just copied it to the clipboard.
Yeah.
So now you can just, oops, wrong one. If you have your simulator console in focus, keyboard input, the simulator takes a keyboard input and sends it to the simulator.
Mm-hmm.
Versus if you have the window open, then it's actually getting keyboard input from the simulator. I mean, from like the Sol itself.
Right.
I had no idea what Control V or Command V was. So now if we execute at 0, so I'm going to show you slow. It's running really, really fast.
Yep.
That's actually why I wanted to show this one. This is cool though. You know, you can single step this one. Hey, how does Trek 80 work? So there's a command called throttle. You have to do, I think I do it in the code now, but you have to do, if you don't have, you have to do,
What did you say? No sleep or something? Is that what it was?
yeah, you have to do the set SIO no sleep because it has like they didn't want the CPU running at 100% when they ran the program. So they just put these little sleeps in there and ran them in certain places.
Mm-hmm.
Sleep 0, just give it the CPU. Well, unfortunately, because the simulator itself is doing a bunch of timing, it messes up the throttle. So if you're going to be using throttle, you have to tell it, don't do your sleeps, so that the simulator can figure out how, basically it tries to figure out how many instructions you're executing every so often, and then it throws its own sleeps in there to try to
Gotcha.
simulate. So I have it told, execute about 220,000 instructions a second. Just for this example. And then we'll do the same thing. You can see it's even loading slower.
So the emulated boards and the like can have an external screen associated.
Yes, there's something called Sim Video
Right.
library, and so yeah, this pretty much works like a Sol. It just gives you a
Right.
bitmap. So I'm using the character generation fonts, and
Yeah. Has anybody done a front panel?
there's some front panel stuff in here, but no.
Okay, because
No
it
one's
seems
done
like if you could launch a separate screen, you could launch a front panel,
Yes.
which could be yeah, or anything that any hardware.
So now it should run. Now it should be running pretty much
Right.
at a normal sol speed. So if you're doing things like you're gonna muck around PC get and put, you're doing X modem transfers, anything that has timing in it, you can enable the throttle command, so your computer runs at your simulator runs hopefully some at a closer speed,
Okay.
than full bore, so your timeouts work. So that I want to show like there are some video things. This is done on the VDM1, and there's what was the other one? Yeah, the Dazzler's in there. Um,
Yeah, I've been using that Dazzler one.
Is the Hayes one
Oh,
an emulated modem?
yeah, that's a Hayes modem,
Okay.
and yeah, and that's a PMMI modem,
Mm-hmm.
which are basically just serial ports.
Right.
It's the Hayes. I think it's the Hayes non-smart modem.
Yeah. Oh, okay. From way back.
Yeah,
Yeah.
and that was done to get the CBBS working.
Mhm.
We have the JAIR is in there now. You can attach like the image that you shove on a SD card, and it'll read that image. It does the FAT. It does everything. So you can muck around with a jar if you want to.
So I think I asked this way back, or earlier time when we were talking. Is there a base sample of if you wanted to add hardware? How would you go about it? In other words, I believe it's written in C from what we talked about back before. But so
Yeah,
say you wanted to do a. I don't think I see the SSM 104 there or something. It listed. It say somebody wanted to go through and somehow emulate that.
yeah.
SSMIO4.
Thank you.
One
Thank
thing
you.
I'm gonna put on the new simulator I'm working on is I'm gonna make like a null device.
Yeah.
It doesn't really do anything, and so but it should show you like the basic structure of a device. Um,
Yeah. And you're looking to extract this CPU card as a device rather than a built-in, right?
yeah, so this is the
Yeah, that would make it easier to emulate different CPU cards.
new S100 simulator that
Hmm.
I'm working on.
Ah, okay.
And now, yeah, so it basically has a bus device, a CPU. It has a RAM. This is just a basic generic
Hmm.
RAM device. But like, if you wanted to do an expando RAM, you'd like
Hmm.
make an expando RAM device, and so it wouldn't have to be integrated and worry about conflicting with all the other devices that are already there. Um, and so I'm hoping it just works a lot. And I've eliminated a lot of just the
Yeah.
like sleeps, and I got rid of all the 68K stuff, because that should be, again, like if you get into the Altair Z80 source code, there's just if statements, if this and if that, and not this and not that, but you're doing this, but not that, but what about this? The code is almost impossible to read because it's just been, but I'll look at so your basic device has this stuff at the top. You tell the simulator the description of your device. The device is broken. You have your device, and the device has units. So like the disk controller is a good one. So you have like your disk controller, and then each drive is a unit.
Hmm.
Yeah.
So you'd have like your disk controller device and 4 units. And this is where, and all these different variables, that kind of tell you what the unit is. Is it a fixed unit? Can you attach it? Can you do this? Can you do that? How, there's all these things you put in for your unit. All those registers we were looking at, like your AF register, your SR register on the CPU, all those go in here. So this doesn't have any registers, but that's where you would basically define all these different registers. These are modifications like if I do like set RAM verbose, then it sets a flag and it puts it into verbose mode. So then the code now, you can have code if verbose, print this, print this, print this, print this, print this. And then you can turn verbose on and off. And these are called modifiers.
Okay.
This is like the modifier. This is where I'll set it where you can say, I don't want 64K now, I'm 48K. A special command, I want to just clear all memory. So you can make these modifiers to do different things. And again, all these ORs, all these bit values mean different things. In fact, let me just show you a different one. This one isn't org. This is the old CPU program. It's not organized well. It's like, here's all your registers. This tells you whether it's a hex register, how many bits the register is, you know, whether it's a flag register, you know, which bit are we looking at? So these are all the registers for the CPU. Here's all the modifications, the mods. So this is, so you can see, like, if you see where my cursor is, if you type in 8080, it's going to call set CPU set chip type with the value chip type 8080. If you type Z80, it's going to call that function with the chip type Z88. This is where you turn your, whether you want to trap or not trap, stop on halt, loop on halt, verbose, quiet, you know, turn your programmed output on and off. So those are all the modifiers. The other nice thing is it has what's called a debug table. And you can set different debug options. Like I want it to log every in operation. I want to log every out operation. I want it to log interrupts. And you can turn those different debug flags off and on to look at different things, or turn them all on or turn them off completely. You can say you want to send the debug to standard out, standard error, send it to a file. And all this stuff I'm showing you here, this is required for every device. Whether whether they're blank, you know, they just end with a null, or there's stuff in there. And then this is the actual, what we call the device table. This gives you the name of the name of the device, which is CPU, where the unit table is, where the register table is, where the modifier table is, where the reset function is. Some of these are like, where do you what function do you do to examine memory, deposit memory? What function do you call to attach a device, detach a device? So a lot, these I think they can all be null.
Gotcha.
And then, so that's like the basic stuff you need to start with the device. And then once you get to the device, gosh. So like, here's your this device, here's the CPU's reset function.
Yeah.
It initializes all your registers. It sets what kind of break types you're going to have. Clears out the history. I mean, it does all this stuff.
Yeah.
Every time you do reset, it does that. And then most of the rest of this stuff, this is just how you're going to handle this particular device. And you can, once you have the required functions in there, then you just surround it with whatever you need. Like the RAM is another easy one. Same kind of thing. The reset device, and this particular one, the reset is called with a flag, whether it's the device is being disabled or being enabled, or disabled or not being disabled. So if the device comes with a disabled flag, then I tell it remove its memory from the memory manager. Or if the device is being enabled, then add its memory to the memory table. And then for the memory, it's just wherever I put it, it says M. It's just a array of bytes that you store and retrieve memory from. This is the examine memory function. There's another function called get byte, another one called put byte. This is the function that gets called when other boards like the CPU board want to get RAM. This is the function that's going to be called. So if it's a read function, it calls get byte. Otherwise, it just puts the byte. Made a put word. So you can just put a word. A function to, if you type the clear command, these are the functions that clear the memory. So I mean this, what is that? 168 lines for the RAM card. It's pretty it's pretty straightforward. So again, I want to make a device that pretty much does nothing as like a template. Just copy it, rename your stuff, and start from there. I don't know if I can get that put into Altair Z80. They may not want it.
Yeah. Yeah, I can understand. Okay. No, that's cool. Thank you. Again, my C is not as strong as far from yours, the strength of you, but I can follow that. I think if I was going to do something, say a RAM card, I'd probably take one that was already existing and look to modify it, if you know what I mean.
I've
copy and tweak. So go ahead.
Like for the Tarbell controller, I started with someone else's disk controller. For the 2SIO, I started that one I may have just done on my own because the SIO one was messed up.
Yeah. So yeah, no, that was a good just a good level of an overview for me. Thank you.
So you'll need to get it's all done on GitHub. So I have just an S100 branch that I'm doing everything on there.
Yeah.
But so I get a book on GitHub or Git.
You should put the links for that in there.
Huh?
Put the links for your GitHub in the chat.
Are you ready to publish that part?
No, I haven't pushed it yet.
Okay. That's oh. Yeah, I'm okay with Git. Nothing amazing. So I actually need to get better at it, to be honest with you.
That's that one. Did it do the H?
Yeah.
Oh, no. Delete. Can I delete one? Delete. Forgot the H. Sim H. So eventually there'll be a you'll see the branch on there. You can just download that branch.
Okay.
Yeah, the SimH.
Excellent.
When Patrick first told me I should use SimH for the Dazzler, I was thinking like, well, I can just do I was just working with my computer, and I just have to do a Alt V to paste into TerraTerm. But then once I tried SimH, it's a Control V, which is a one-handed type of thing versus Alt V. And so I started using SimH for all my Dazzler programs.
Yeah, it's a really cool program.
Oh yeah. I mean, what I found is, I have stuff out here in the garage, and then when I'm in the house in the office, so I don't have equipment there, but SimH, the Altair emulator and SimH and that kind of thing, I can play around with stuff like almost like I'm here, kind of thing.
Yeah.
And
then I love it because then you can take those disk images that you're using in the simulator, put it on your ESP32, and do your Altair with the exact same image.
Yeah.
That's amazing. And then run, flop to PC, put it on an 8-inch disc, and boot off 8-inch disc. It's just amazing.
Yeah, haven't got the 8-inch discs going. I did have 5.25 going. It's actually disassembled right now, but I definitely got some 5.25 running there for a while, which was exciting.
Okay.
So that's kind of all I.
No, that's awesome, man.
Good.
Thank you for the presentation. I think that'll help a lot of people if you know, when they see it published and stuff.
Hmm. Yeah, and that's so those disk images that you get from like Peter's site, you can't put those on the ESP32, or you can't do anything with them. They will only run on the simulator to my knowledge.
But if you go through and generate, you can generate disk images on the simulator that can run on the ESP32, correct?
Yeah, yeah, any of the
Yeah.
ones that follow the MITS format.
Yeah.
Yeah, pretty much anything from Mike's site.
I've pulled a lot from there as well. So
Yeah, because he works with, all that stuff ran on hardware.
yeah. Okay, I didn't know that about Peter's stuff though, so that's good heads up on that. I would have tried it and sat there banging my head and
Yeah,
wondering why
why
isn't
is this
this
working?
working?
Well, like I was doing it with the simulator. I was more like, for me, it was more like, how come nothing from Mike's site can boot? What is the problem?
Yeah,
And then I figured out, well, I'm just going to try the actual MITS bootloader, and then whoop, everything came right up.
yeah,
I wonder if because normally on the disk image, on an actual physical disk image, you've got a bootloader on the disk that's ahead of the rest of the disk, right?
Yes.
Which is probably why they're jumping over that.
Yeah, for some reason they either don't use it and they just kind
Right,
of load an image off disk into RAM. I'm
right.
not sure what they're doing exactly.
But they're bypassing the bootloader and loading
Yeah.
directly, it sounds like.
Yeah, like I said, it's very just so I mean, I was talking to Pete about fixing that, and that's when I came to the realization that Altair Z80 is more of a like software simulator. Like
Hmm.
we don't know, it doesn't matter how we actually get CPM running on the machine, as long as CPM runs, we're good.
Right,
Versus, no, we want it to be like a
right.
match the hardware. And you should be able to take something that's you're running on your Altair and run
Hmm.
it on the simulator.
Right.
And that's kind of where
Yeah.
that's kind of the one I'm working on. It's
Yeah.
more idea. I'm trying to make it more hardware accurate, I guess,
Hmm.
than just it'll boost a particular version of CPM.
Cool.
and one question on the which I think I tried to look for it and I couldn't find it. The MITS disk bootloader dbl.bin that you had. Where did you grab that from?
Oh, that's from Mike's site.
Okay, I'll have to go up to Mike's site and look for it because
I know where it is. Um,
Yeah, he has a lot of ROM images on his site, and some of them the code as well, right?
yeah,
yeah, he has a lot on his site. I think you know.
Right. Original ROMs, yeah, and then yes. Right. Oh, and it's got the code as well as hex files. So you can,
yeah.
yeah,
It's so I've been
There you
just
are.
so back in the day, the simulator wouldn't load a hex file; it would only load a
Yeah.
binary. So I did, a hex to bin, and I've been using
Mhm.
that. But now you can just download the hex file and load it if you want.
Okay.
I'll put
Yeah.
I think I just need to download Mike's site.
I know. I I wanna like copy the whole thing and just put it on GitHub.
Yeah, we should we
That's,
should we should reach out to him and say, can you add a download site, a download all your downloads button on your
that's
site, please?
It's such an amazing site. There's
Oh
so
it
yeah,
much
really
stuff here.
is.
He's done just
yeah.
that guy's done so much for the hobby. It's
Hey, he's such a
Oh,
nice guy.
absolutely.
I've talked to him a couple times when I bought stuff from him, and he's such a nice guy.
he is, and
Yeah.
just yeah. If we had awards, I'd nominate
Yeah.
him.
Yeah, there we are.
Yeah, all these, pretty much
Mhm.
everything in here should run on the simulator with the right bootloader.
Yeah.
I brought it launched in just a slightly different spot. So hold on a second. Okay, we'll try to share. Select the window. We'll go with that one. Allow. And
There we go.
There you go.
okay, let me go full screen. So I just when I came across this way back when, I really got a kick out of it. When you flip it on, and you guys may not hear it, but you flip it on, and actually you hear the fan running, and
put the link in the chat.
yeah, I will. I'll
And
grab that right now.
that's a real Altair picture.
Yeah, oh yeah, I mean you can
A good one.
reset, run, stop, single step. I mean you can go through. I haven't played a lot with it, but I give somebody credit for going through and making the the effort
Oh wow,
of
the
doing
switches.
everything.
Oh, that's awesome.
Yeah,
Yeah.
and you're hearing. I mean, I'm hearing. You may not be hearing. I'm hearing clicks.
Yeah, I heard
Each
it
one. The
click.
fan run, oh, you're hearing it. Fan running. Honestly, if I haven't played enough with the front thing to, um, reset type thing. But it was just. I felt somebody really put a lot of effort. And you can have some fun with it. So yeah, I'll throw it in the chat, Walt. So.
I wonder if you can tell it to have pin 46 float.
There you are. Let me throw that in there. Paste.
There you go.
Okay, that's it right there, bud.
Oh, that's neat.
Yeah, I thought that was fun. I'm gonna. I could probably. Did I stop sharing? I'm gonna stop sharing. Yeah,
I
I
was
just
playing with that a little bit one day when I was just toggling in a couple of little programs that I found, and
yeah.